So on the first two, when we're adding and subtracting, the first thing we're going to have to do is what? Get a common denominator. So the first one, we have 4 and 5. So the smallest number that 4 and 5 both go into is 20. So we're going to use 20 as our common denominator. So we're going to have something over 20 plus something over 20. Now for the first fraction, the 3/4, what do we have to multiply by 4 to make that a 20 in the bottom? Okay, so we'll do the same thing on top. 3 times 5 is 15. All right, and then the other one, we want to turn this 5 into a 20. So what are we going to have to multiply there? 4. So we multiply by 4 on top and get 8. Okay, now that we have a common denominator, we've changed the numerators and denominators of both my fractions. Now we can add them together. What is 15 over 20 plus 8 over 20? Good, so we add the tops and the bottom stays the same. That is an improper fraction. Do we need to change it to a mixed number? No, leave it as an improper fraction. Okay, actually improper fractions are easier to work with. If we were going to add something else on, or if we subtract something or multiply something, it would be a lot easier with an improper fraction than a mixed number. Okay, the next one, we have 2/3 minus 6/7. So what's our common denominator going to be there? 21. All right, so we're going to have something over 21 minus something over 21. What do we multiply that first one by to get 21 on the bottom? 7. So we multiply by 7 on top, and we get 14. Okay. And then the other one, what do we multiply by here to get 21 on the bottom? 3. So we multiply by 3 on top and get 18. All right, so we have 14 over 21 minus 18 over 21. Is this 14 positive or negative? Positive. Is the 18 positive or negative? Negative. So we have positives and negatives, so that means that they're going to add or cancel. They're going to cancel, right? So when they cancel, what's going to be left? So what's 18 minus 14? 4. And why is it negative? I'm hearing a bunch of people say it's negative. Because the 18's bigger and the 18's negative. Good. And then on the bottom? Can we simplify that? No. There's nothing that goes into 4 that also goes into 21, so we cannot simplify. Now, I want to make a quick point right here. I put the negative on the 4 like this. There's one other place that we could put the negative, and that would be okay. Anybody know where that would be? So the other way you could write it, if we have 4 over 21 but want to show that it's negative, instead of putting it in front of the 4, where else could we put the negative? Yeah, right out in front, right in the middle, like that. Okay, this would be okay also. It would not be okay to put the negative down here with the 21. You never want the denominator to be negative. All right, so you either put the negative on top with the numerator, or you can put it out in front of the whole thing. So either way is okay, whichever way you like better. So when we're multiplying, what are we going to do here? We're going to go straight across, exactly. So when we do this, we're going to do 2 times 9 and get 18. And we're going to do 15 times 8 and get, what is it? 100 something? 120? Okay. And is that our final answer? No, we're going to have to reduce, right? I'm going to give myself a little more room here. I'm going to put it underneath. So looking at this one personally, I would probably divide by 2. Why? Because both numbers are what? Oh. How do we know they're both divisible by 2? They're both even, exactly. Since they're both even, we know they're both divisible by 2, so let's start by dividing by 2. 18 divided by 2 is 9, and 120 divided by 2 is 60. Okay? Can I divide by 2 again? Is 9 divisible by 2? No, so we can't divide by 2. So we need to check and make sure nothing else goes into both of them. What else goes into 9? 3? So how can we check to see if 3 goes into 60? Because you may not know that off the top of your head. what could you use?
Calculator.
Calculator, right? Just type it in your calculator and see if it works. So try it. 60 divided by 3. We get an even number, Jordan? Yeah, so we can reduce by 3 here. So Jordan, what do we get? Well, let's go ahead and do the bottom since that's what we were talking about. What's 60 divided by 3, Jordan? 20. And on top, what's 9 divided by 3? 3. Okay. Can I reduce again? No. So the only thing that goes into 3 is 3, right? Does 3 go into 20? No. So we're done. Now, there is another way to do that where we can reduce before we multiply. So before we do 2 times 9 and 15 times 8, we can reduce, and then we won't have to reduce in the end. Either way, we're going to reduce the fractions, but I like the other way because then we get to work with smaller numbers. Remember yesterday when we talked about using the least common denominator because we get to work with smaller numbers. We can do that here by reducing first, and we'll talk about that with our notes today. All right, with the division, what do we have to do before we can figure out what this is going to be? So we talked yesterday about the KFC thing, not the place that sells chicken, but yeah. So the K stands for keep, the F stands for flip, and the C stands for change, or chicken. So what do we keep? Which part of this problem do we keep the same?
5/6.
The first part, right? The 5/6. All right, so the 5/6 stays the same. Which part do we flip? The other fraction, the 3/4, that becomes 4/3. And then what do we change? Division changes to multiplication. Okay, now we have a problem that's just like the last one. Okay, just like the multiplication problem we had before where we multiply straight across and then we'll reduce if we can. So multiplying across, what is 5 times 4? 20. So we get 20 on top. And on the bottom, 6 times 3 is 18. Okay, can that reduce? Or simplify? Yeah, kind of like this one over here. Both numbers are even, right? So if both numbers are even, we know what goes into it. 2. 20 divided by 2 is 10. 18 divided by 2 is 9. Can we simplify that? No. So the only things that go into 10 are 5 and 2. And neither one of those goes into 9, so we're done. Even though this is an improper fraction, we're going to leave it like that.